Welcome back to Science Modernizers. Today we are actually going to see June 2022 further mathematics and June 2021 the first two questions on differential equations. Actually the question reads find the complementary function of the differential equation d2y on dx squared plus 6dy on dx plus 9y equal to e to the negative 3x. From there, the question says you should find the complementary function of that differential equation in the form y equal to f of x. Hence, find the particular integral and the general solution in the form y equal to f of x. So let's get started. In general, to find the complementary function y of c, we shall begin by defining the auxiliary equation of the second derivative equation e to the negative 3x, which is given by m squared plus 6m plus 9 equal to 0. Factorizing the equation, we get m plus 3 all squared equal to 0, and that is if only if m is equal to minus 3. And we clearly see that the roots of this differential equation are real and equal. So hence the complementary function y of c will be given by y of c equal to a plus bx e raised to the alpha x, where alpha is the root, that is negative 3. So from there we can have a y complementary to be a plus bx e times e raised to the negative 3x. So that's the first part of the equation. The second part says we should hence find the particular integral and the general solution in the form y equal to f of x. The general solution of a differential equation is given by the complementary function plus the particular function. So we are going to notice that in this question the particular function was not given, the particular integral, so yp was not given. So we will have to define a particular integral in this case, and the particular integral shall be defined as yp equal to ax squared e to the negative 3x. Now we use this particular integral since if we use ax e raised to the negative 3x, we are going to realize that when we differentiate this function twice and substitute in the differentiation, that is this equation won't be defined when we shall substitute inside the differential equation. The reason why we have to compare this particular integral with the complementary function which we had above. So from there we are going to obtain the derivative of this, and the derivative of this is simply given by yp prime is equal to 2ax e to the negative 3x minus 3ax squared e to the negative 3x. And if you obtain the second derivative of this function, we shall have yp prime equal to 2a e to the negative 3x minus 6ax e to the negative 3x minus 6ax e to the negative 3x again plus 9ax squared e to the negative 3x. That's just differentiating that, passing through the product rule. And then if you substitute the value of yp prime and yp prime in a differential equation, this we shall get this statement where this is the second derivative, all of this is the second derivative plus 6 into the first derivative plus 9 equal to e to the negative 3x. Then from there we have 2a minus 12ax plus 18ax squared plus 12ax minus 18ax squared equal to 1. That is cancelling e to the negative 3 since it's a common thing, it's common everywhere on the equation. So here we definitely get 2a is equal to 1 since the negative 12ax and negative 12ax will cancel out, and 18ax squared minus 18ax squared will cancel out, so we'll be left with 2a equal to 1 where a is equal to half. So with that said, so the y particular will actually be given by yp is equal to a half x squared e to the negative 3x. So therefore we can now write the expression of the general solution, which is yj is equal to the complementary function a plus bx e to the negative 3x plus a half x squared e to the negative 3x. So that's what was asked in 2021. Now let's see what was given in June 2021 paper 2. It was actually a very similar problem. So let's actually see what is stated. So the question was find the complementary function of the differential equation d2y on dx squared plus 4dy on dx plus 4y equal to e to the negative 2x in the form y equal to f of x. Hence find the particular integral and the general solution in the form y equal to f of x. So let's get started. To find the complementary function y of c, we shall still define the auxiliary equation, and the auxiliary equation will be given by m squared plus 4m plus 4 equal to 0. And from here, if you factorize, we are going to get m plus 2 all squared equal to 0, if only if m is equal to negative 2. Hence, the complementary function yc will be given by yc is equal to a plus bx e to the alpha x as seen in the previous case. So y complementary in this case will be a plus bx times e raised to negative x. And now the b part of the question says we should find the general solution. And we saw that the general solution is equal to y complementary plus y particular, where yp is the particular integral. So we are still going to let our yp to be ax squared e to the negative 2x, whereby when we differentiate, we have this statement as using the product rule. You keep ax, you keep e to the negative 2x constant, and you differentiate ax squared, where we get 2ax e to the negative 2x. Then we keep ax squared constant and we differentiate e to the negative 2x, which we have negative 2ax squared e to the negative 2x. We do a similar thing for to obtain the second derivative, and we substitute in the differential equation, where we get this statement. And simplifying this, as in the previous case, we clearly see that 2a is equal to 1, implying that a is equal to a half. So the problem is very similar to that which came in 2022. So in general, the particular integral will be given by a half x squared e to the negative x, since a is equal to half, and hence the general solution will be given by y complementary plus y particular. Therefore, we have a general solution to be a plus bx e to the negative 2x plus a half x squared e to the negative 2x. Thanks for watching. See you in the next video. Please share and subscribe. Stay blessed and stay tuned.